So, good evening everybody, and thank you for the invitation to come and talk to Knowle Astro. So this is, as you can see from the title, a light-hearted look at astronomy, and I'm assuming that everybody is okay with what's on the blackboard there as a starting point before we sort of ramp it up a little bit and start getting a little more technical. So what I'm going to be dealing with here is looking at a light-hearted look at astronomers, at telescopes, observatories, and probably not a great deal of time for miscellaneous, as I didn't want to take up 3 or 4 hours of your time this evening. So, as we know, some astronomers are scientists, and if any scientist is asked the question, so you think you have what it takes to be a scientist, the answer from Sir Patrick would of course be,
well, we just don't know.
And yes, on the right hand side you see the thought bubble there of a scientist, and yes, that is precisely what's going through my head pretty much all the time, every day. So yes, some astronomers are scientists and some astronomers are astrophysicists. And an astrophysicist is capable of taking a wonderful science like astronomy, or even a hobby like astronomy, and taking it from a rather wonderful thing of contemplating the universe and turning it into absolute gibberish, as we can see on this blackboard here. But if astronomers are astrophysicists or scientists, there's an awful lot of them out there, and we might ask the question, well, can we sort of package them together? Can we classify them in some way that makes sense? After all, astronomers spend their time classifying stars, and we can plot stars according to their surface temperature along the horizontal axis here on the bottom, from cold stars to hot stars, the surface temperature from a few thousand to many tens of thousands of degrees. And we can plot the star according to its luminosity, going up in the vertical sense, from very low luminosity stars at the bottom to high luminosity stars at the top. And then we see, if we plot the stars according to their colour, according to their luminosity, we find that we get certain groupings of stars. Dwarfs at the bottom, giants and supergiants at the top, and the main sequence running across the diagonal. So if astronomers do that for stars to try and classify and catalogue them, somebody asked the question, why can't we do the same for astronomers? So they thought, how should we plot astronomers on an HR or so-called Hertzsprung-Russell diagram? Why can't we plot astronomers the same way? Let's plot the luminosity of an astronomer by their fame, which we can quantify by asking how many hits do we get if we Google their name. So obscure astronomers at the bottom, very famous astronomers at the top. And on the horizontal scale, just like the colour going from cold on the right to hot on the left, we can put their scientific output. In other words, how prolific are they as scientists? The right-hand side indicating they have produced very few scientific papers, and on the left-hand side, an enormous number of scientific papers. And then we can plot various people on this so-called HR diagram of astronomers. So, if this was a real talk, I'd ask for a show of hands, but that's far too difficult at this point. So I'll just ask the question, who do you think is that star there in the very top left-hand corner, the highest level of fame and the largest number of scientific papers? In that top left-hand corner, who do you think that might be? I'll just give you a couple of seconds to ponder. Who do you think is highest on the fame rating and has a very large number of scientific papers? That is Carl Sagan. Right next door to him, arguably slightly more famous, but with slightly fewer papers, is Stephen Hawking. If we go a little further along, just as famous, but with somewhat fewer papers, we have Brian Cox. And then we have this individual. I'm not even sure why they're on this diagram. This particular individual is almost as famous as those three astronomers, but apparently is a non-scientist because this individual doesn't have any scientific papers. This is Mylene Klass. I'm not quite sure why she's on the diagram, but perhaps that's a sort of calibration point. And there's other individuals you've probably heard of. Neil deGrasse Tyson, Chris Lintott, Professor Jocelyn Bell Burnell. This particular diagram is probably a few years out of date, but you get an idea of how these individuals are scattered through the diagram. Of course, there's not many famous people down the bottom because by definition, the bottom of this diagram are people that are not particularly famous. But given that we can quantify the vertical position by Google hits to specify the fame, and given that the number of scientific papers of an individual is a well-known quantity, when I saw this diagram, as well as being interested as to where famous people were scattered, I also thought to myself, where would I be on this diagram? I'm a scientist, so I've published scientific papers, a little over 100. And so I thought, well, let's do the obvious thing. Let's Google myself and see what I get. Googling Steve Barrett doesn't help because there's far too many Steve Barretts in the world. Dr. Steve Barrett doesn't help because there is a Dr. Steve Barrett in the States and I'm sure others. So I tried Googling Dr. Steve Barrett and Liverpool to try and make sure it was me and not somebody else. That gave me a result of about 5,000 hits. So I thought, right, I can now place myself in this diagram. 5,000 hits on the vertical scale and a little over 100 scientific papers. That means that puts me there, right in the middle of the main sequence. Fantastic. I'm not a supergiant, I'm a main sequence scientist. It tells me what I've known all along. I am completely mediocre. Fantastic. It's nice to know where I sit relative to these giants of the astronomy world. Let's look back to where astronomy started. What was the first telescope? No, not Galileo. The first telescope was used by these gentlemen here. You can see the caveman looking through this hollow log at the moon, asking, you say this is the most powerful one you have? There's clearly small hollow logs and large hollow logs, and this individual is rather disappointed that the rather expensive and large hollow log doesn't show the moon any better than any of the others. I find it interesting for that reason, but also I find it interesting to see that the telescope in the background, that hollow log, has a little finder hollow log strapped to the side, as we all know, very useful for making sure you're pointing in the right direction. But what I actually find funniest about this little cartoon is the fact that this individual who's contemplating buying a telescope for $8 is clearly buying it from another caveman with a rather coiffured hairdo, who is clearly the salesman because this particular caveman is wearing a tie. Fantastic, what a great idea. Again, an early astronomical device, the sundial. We know what those are, we know how they work. Here's an individual who's realizing that the sun is about to be eclipsed, and then there's a total eclipse and the world goes dark, and then the sun reappears. At which point he has to call in the sundial repairman. Why? Well, because once the sun had returned after the eclipse, it just keeps blinking 12 o'clock. I thought that was a wonderful idea for a sundial that doesn't work after a total eclipse when the sun returns once more. And of course there's plenty of other astronomical devices for measuring either the time of day, or perhaps it's a clock, perhaps it's a calendar, perhaps Stonehenge is many things. But of course you can see one of the architects talking to the other, having put all of these stones together to make a clock or a calendar. The problem, of course, as we all know, is that when summertime ends, everything has to be turned ever so slightly to the left to make sure it continues to read the correct time. How do people move these heavy stones in order to make these ancient calendars or clocks? Well, some people might say it's a mystery. If you ask the question, how did they manage to move these massive stones? Sir Patrick might say, well, we just don't know. But again, that's missing the point that there is actually a clue on the left-hand side as to how these stones might have been moved. If we have a think about some famous astronomers, I'm not going to deal with all of those. Let's pick 2 or 3 out of here. Let's think about Galileo. Galileo, of course, made some observations with an early telescope, but he was also a great scientist, not just an astronomer. He allegedly dropped different sized cannonballs from the top of the Leaning Tower of Pisa and noted how they fell to start thinking about how gravity works. Up till that time it was assumed that of course a heavier object would hit the ground first, whereas Galileo preferred to do an experiment and see what actually happens rather than what is supposed to happen. But of course, timing events is rather tricky when you haven't got an accurate clock. If you've only got your pulse to work with, then that's subject to error. And people have sometimes wondered, well, if there were computers in Galileo's time, how much would science have been improved because you no longer had to rely on simply taking your pulse as a measurement of a time interval? Well, if there were computers in Galileo's time, well, I don't think things would have been very different. Instead of throwing cannonballs off the top, he probably would have thrown computers off the top of the Leaning Tower of Pisa to see which one crashed to the ground first. What about our friend Isaac Newton? Everybody knows the story that he was sitting under a tree in his apple orchard outside Woolsthorpe Manor. And while sitting there reading, an apple fell on his head, and that got him thinking about gravity. So basically he came up with the universal law of gravity because of an apple falling on his head. That is a well-known, if perhaps apocryphal, story. What is not so widely known is that after Newton discovered gravity because of an apple falling on his head, a little later that same afternoon, Newton discovered comedy. And again, not very well known unless you really dig into the archives, that Newton made various contributions to natural philosophy, but his biggest contribution to philosophy occurred that evening when he discovered surrealism. I like the way the apple is now being thrown out of his hand by the grand piano. What about our friend Carl Sagan? I'm sure some of you, if not many of you, will remember Carl Sagan's wonderful series Cosmos back in the 70s. And I saw this rather nice cartoon from The Far Side from Gary Larson. Just look at all those stars. There must be hundreds of them, he says as a kid. If you don't understand that joke, then you don't remember how Carl Sagan used to alliterate the various large numbers during his Cosmos series. Let's have a look at telescopes. Amateurs, of course, are wonderful at coming up with new ways of using telescopes. These days, perhaps we're more likely to buy one, but many amateurs prefer to build their own and possibly even design their own. So whether this particular design ever made it into manufacture, I somehow doubt. It looks to me like the particular arrangement of this telescope was designed such that the telescope eyepiece would remain fixed, regardless of where the telescope was pointing in the sky. So in that sense, it's quite an interesting design, though I don't think it's anything like as robust or as sturdy as one would like for any telescope that you would like to point at the sky and observe with high magnification. Some amateurs, of course, are extremely skilled at making telescopes. This particular beautiful looking object, I believe this was manufactured out of not just any old bits of metal, but this was manufactured out of either stainless steel, or I've also read it's been made out of titanium, which is a very difficult metal to work. And of course very expensive as well. So whether or not shiny bits of metal are the best way of making a telescope, a reflecting telescope, where the last thing you want is extra reflections of the object you're looking at, regardless of that, it's obviously an example of a huge amount of skill on the part of the person who put that together. At the other end of the spectrum, I think we have some amateurs who try to make telescopes and they really don't have a clue what they're doing. But there we go, that's life, isn't it? Let's have a look at some of these telescopes. Let's have a look at the smallest end of the telescope range. What about fork-mounted telescopes? Perhaps some of you have a fork-mounted telescope. Yeah? Schmidt-Cassegrain, perhaps, something like that. I doubt if any of you have got a fork-mounted telescope that looks quite like this. A lovely idea of a small telescope, fork-mounted, because clearly it's on a fork, and the knife, fork and spoon actually make a tripod. What a wonderful idea of combining a tripod with a fork mount for this small telescope. And if you want the best telescope in the world, well, what do? Well, of course, you get yourself a Carlsberg beer can. And you put a small mirror in this end, and you have an eyepiece with a small 45-degree mirror effectively attached to the eyepiece itself. And I'm told that this particular telescope does indeed work as a small Newtonian. I'm not sure about the optical quality, I'm not sure about how easy it is to collimate. Whether or not it is indeed the best telescope in the world, well, perhaps that's simply a matter of opinion. Sometimes when you think to yourself, I would like a telescope so I can observe the universe, sometimes one is not enough. And for some people, if you're going to use a pair of binoculars, you don't have a small set of optics. You make a large Dobsonian telescope and you double up to make a huge pair of binoculars. So each eyepiece here is fed by one of these two Dobsonian telescopes. Quite a wonderful idea. Whether you regard that as overkill or not, well, you know, you get wonderful views from binoculars, so why not use both eyes, and why limit yourself to having light from one telescope split into two eyepieces when you can have one eyepiece for each telescope. And you're not limited to the size there. You can go up a notch. I'm not too sure what that size is. It's perhaps, I don't know, 14, 16 inches perhaps for the mirrors on this particular binocular telescope. You can see this is a particular skeleton design, and the eyepiece looks like it's a little bit awkward to get to at the top there, but with the right stepladder I'm sure it can point to any object in the sky to give you wonderful views. For some people one telescope isn't enough and you need two, but for some even two is not enough. And some people have gone down a different route for imaging the night sky, and they said, well, if we can buy telephoto lenses, for instance this 400mm telephoto lens from Canon, why should we limit ourselves to a large telescope collecting light and then feeding one camera, where in principle we can have lots of lenses feeding lots of cameras? So why not have 10 of these lenses feeding 10 cameras? One of the advantages of doing that is that A, you can build it up slowly. You don't have to invest a huge amount of money in a very large telescope. You can buy yourself one lens and one camera, and then slowly, as money becomes available, build up. Yes, if you want 10, that's going to be 10 lenses and 10 cameras. It starts to become rather expensive, but arguably it's still cheaper than a telescope with a mirror of an equivalent light gathering power. You can see in this case with 10 of these there's quite a few kilograms there, so you need quite a substantial equatorial mount in order to mount all of these. And again, of course, another advantage is that because you've got 10 lenses and 10 cameras, each of those cameras can be set with a different filter. So if you wish, you can have a couple of cameras taking images in the H-alpha band, a couple in oxygen, and a couple taking luminosity, and one taking red, one taking green, one taking blue. You can do all of that simultaneously and obtain multiple filters at the same time. And if you think that's a good idea, why stop at 10? Why not go up and go to 24? And in this particular case, this arrangement, the so-called dragonfly arrangement, you can see why it has that name from the way ultimately the telescope starts to appear in terms of light going into 24 separate lenses. This particular setup, I believe this is the University of Toronto, I believe. They now have 48. Again, as monies become available, they add to the set of optics that they have. For those that prefer just simply going for larger mirrors, well, you don't take that particular route. If you think size matters, well, you can simply go to the largest Dobsonian you can afford. So there is a very large Dobsonian. We can't see the mirror at the bottom. But it looks like it's a substantial fraction of 1 meter in diameter. You can see where the eyepiece is if you have the standard Newtonian design of a Dobsonian telescope, and you can see the size of the stepladder you need in order to make your observations. So if you fancy being in total darkness, and by the looks of the place that we're looking at here, I would imagine that once it gets dark, there's no artificial light making this light polluted. So when it gets dark, I would imagine it gets very dark, and if you can really pluck up the courage to go up a stepladder like that in order to get to the eyepiece, well, good luck to you. That's fair enough. What do you think the largest refractor ever made is? A lot of people believe that would be the 40-inch Yerkes refractor in Wisconsin in the United States. But I believe the largest one ever made is the one made for the 1900 Great Exhibition in Paris, where the objective lens of this telescope is 48 inches in diameter, a little bit larger than the Yerkes refractor. So the telescope itself is mounted horizontally and fixed in position because it's simply too large and too heavy to move. And so the telescope looks at a flat mirror, a so-called siderostat, and that mirror is moved by this mechanism behind it such that light from any part of the sky is reflected into the telescope. The other end of the telescope from the objective way over to the right would be either an eyepiece or a photographic plate. And the top here you can see an elevation of where this telescope system was constructed. There's the telescope occupying most of the centre of this particular building, supported on these various piers. The 48-inch objective is at this end, and there's the siderostat, so that light coming down from different parts of the sky are reflected into the telescope. And if an eyepiece is placed at this far end, then if the siderostat is pointed at the sun or the moon, then using eyepiece projection you would get a huge view of the moon or the sun displayed on a huge auditorium screen here, much to the delight of the thousands of people in this darkened room, who would then see sunspots in all their glory or exquisite detail in some of the craters on the moon. I doubt it's ever been used seriously for looking at the stars, because if you want to project the image onto a large screen you need something nice and bright like the sun or the moon. If we take a look at what that looked like looking down the length of the telescope, that's what it looks like from not the business end. The objective is down the far end of the telescope, and here we have the eyepiece or the film holder. In this case there's a film holder. It looks absolutely huge. Something of order 2 foot square plates, I think, were needed to actually take photographs using this telescope. And in order to get the focus right, you can see that this end of the telescope is on wheels, so that the whole back end of the telescope moves a little bit to make sure you're at the correct focus. Instead of the photographic plate, you can replace it with an eyepiece holder. I couldn't find any images of the eyepiece itself, which clearly fits into this particular point here, but clearly the eyepiece would be absolutely huge when you compare to the size of a person. So quite an amazing telescope. Unfortunately, after the Great Exhibition, it was effectively dismantled and a lot of it was scrapped. I think the lens has gone into a museum. The rest of it was simply melted down for scrap, which is a bit of a shame. Some amateurs, rather than work in metal and produce large telescopes, they prefer to work in wood. Just because you're working in wood doesn't mean you necessarily make the telescope very small. One enterprising individual decided to make himself a full-size working model of the Hubble Space Telescope. I'm not quite sure what he used for a mirror, whether he got round to that, but it looks to me like it's something made of perhaps plywood pieces, and I'm told it's full size, so you need quite a large garage in order to make a full-size replica of the Hubble Space Telescope. Most people would prefer something a little bit smaller, and some people have made Dobsonian telescopes out of wood, and they are absolutely spectacular works of art in their own right. Some people prefer to buy the optical tube assembly, but perhaps still make the rest of the telescope, the fork mounting and the equatorial drive, etc., themselves out of wood. So again, it depends on where your expertise lies. An individual like Russell Porter, who is an expert amateur telescope maker, has made telescopes such as this, which is both a work of art and a functioning telescope. The mirror is down here in the bowl, and you can see a small eyepiece with a 45-degree mirror. So this is effectively an open truss type arrangement of a Newtonian telescope, which is also a fantastic garden ornament. A lot of amateurs, if they build their telescopes, would like to then put them inside an observatory, possibly in their back garden. That's what I call an observatory, on top of Palomar Mountain, where the 5-metre or 200-inch telescope is housed. I visited that back in 1982. That's me as a student, with slightly longer hair back in those days. But when I visited the 5-metre telescope, I thought that is a fantastic observatory, and it's a fantastic observatory dome. It only weighs about 1,000 tons or so, so I'm sure we can make ourselves one. One day, when I'm older, I'm going to have a house with a garden big enough to have an observatory like that in the back garden. That's what I said in 1982. Some 20 years later, I had a house with a back garden, and I compromised slightly and decided to go with a shed from B&Q, which I then modified by making a hole in the base to allow the pier to come through from the foundations beneath, and gave it a sort of flip-off roof, if you like. So not quite the same, but I still aspire to the left-hand side, even if I'm currently using the right-hand side. Of course, by buying a shed from B&Q, I haven't put a great deal of my craftsmanship into that particular observatory, whereas other amateurs put their heart and soul into the observatory, which is going to house their pride and joy of their telescope. I'm not quite sure how big that is. Perhaps you can judge it from the size of the padlock or the hasp. Perhaps a gardener might be able to judge it from the flowers in the foreground, but I would imagine that's of order a couple of meters or so in diameter. But look at that geodesic dome. A lot of love has gone into making that. Rather than simply buying a fiberglass dome, they put a great deal of time and effort and love into making that beautiful craftsmanship there. But of course, one of the disadvantages of having an observatory in your back garden, it's great that you can at any time go into your back garden, open up, and your telescope is there and essentially ready to go. But part of the problem is your back garden might not be in the darkest area that you would like to observe the sky from. So rather than having a fixed observatory in your back garden, wouldn't it be better to have a telescope which you can move around and have an observatory, if you like, an observatory on wheels that you can take to wherever you have the darkest skies in your neighbourhood? And some people have gone down that line, saying, I'm not going to put effort into making an observatory in my back garden. What I'm going to do is get myself one of these. What a fantastic caravan that is. So there we have a half caravan, half observatory. Looks like it might be quite large, but yep, just think what you can do. Tow it to where your darkest skies are, hitch up for the night, open up the observatory, do your stargazing, and at whatever time in the morning you decide you've had enough, you close up the observatory and you crash in the bed that's sitting right next to it. Fantastic idea. Now, it might be that your particular car is perhaps not large enough to tow an observatory like that around, and perhaps you would be rather unhappy with the idea of so many tons being pulled behind your car. So you might want to go for something just a little bit smaller, just a little bit more compact, but still an observatory. So you might want to consider something like this, something altogether perhaps more manageable. So that's one way of doing astronomy on the move. But an alternative, of course, is to take a telescope somewhere. You don't necessarily need an observatory. If you want to take a telescope into the middle of a field that's nice and dark to give you your nice dark skies, then perhaps you don't need to take the dome with you. You just make sure that your telescope is mobile. And there are plenty of go-to telescopes around. There's a wonderful looking go-to telescope. It looks like an equatorial Newtonian. Not too sure of the mirror size again, but I also am not too sure whether you need a license to drive one of these things. But it looks like that is a go-anywhere telescope. If you've got a dark sky in the local park or somewhere not too far away from where you live, then you get that running, you trundle along to your dark sky site, and then you use this wonderful looking semi-Dobsonian type telescope. That's not the first example of using a telescope that's mobile, because there are other ways of making telescopes mobile rather than buy a telescope and then attach a couple of wheels to it. There's another way of making telescopes mobile, and that is to say, well, why don't we just attach a telescope to the roof of a car? Great idea. So this picture, which I'm not too sure of the date, is it 50s, is it 60s? The design of the car is slightly at odds with the design of the telescope, but here there's a something like 8 or 9 inch refractor, beautiful looking instrument, on the roof of a car. And you might say to yourself, well, surely that's of limited use. Won't the car rock slightly while the telescope is being used? And surely the telescope will be limited to only looking at a little bit above the horizon simply because of the way it's mounted on the roof of the car. Well, actually, not so. You can rack up the central support pillar, and there you can see that the telescope can indeed see from the horizon up to very high altitudes, as demonstrated by this gentleman there. So, is this a publicity shot of some kind? Did it ever exist? Was it ever used in serious use as an observational telescope? Or was it used as a piece of advertising? Was it advertising the telescope? Was it advertising how versatile the car is? I'm not too sure because I couldn't find any background information other than these wonderful images of how it might be used. As astronomers, as amateur astronomers, we might look at that and say, no, it's obviously an absolutely crazy idea to put a large refracting telescope on the roof of a car. Nobody is going to be so crazy as to actually do that. Unless you're in America, in which case you can see it makes perfect sense. We now have a Volvo, which perhaps can take a little more weight, and what appears to be quite a substantial refracting telescope on the back end. In many respects similar to the one we've just seen. Perhaps that's 6, 7, 8 inches in diameter. I'm not too sure what the objective would be there. In this case, this gentleman, who I believe lives in Florida, has propped up the back bumper of the Volvo so as to minimise the amount of movement due to the suspension of the wheels when it's being used as a telescope. In this particular case, again, I would suspect that it can't be used above a particular altitude, but who cares? So in this case, I guess this gentleman would drive out to dark skies and then use this particular telescope. So just because the previous pictures made it look a little ridiculous doesn't stop various people giving it a go. That's the wonderful thing about amateur astronomers. They're never afraid to give something a go. So is this Televolvo the sort of limit as to how big a telescope you could possibly make mobile and take to where you want to use it? Well, the only example I could find that was actually a bigger telescope than this, that was still mobile, was SOFIA, the Stratospheric Observatory for Infrared Astronomy. A little bit of a mouthful there. And here we can see the telescope that's in the back end of the 747 with a large door that opens so that this particular infrared telescope can look at the sky. It's in the back of a 747 so that the 747 can fly as high as possible above most of the atmosphere that tends to absorb the infrared. So that is the ultimate telescope 747. But I think we're getting a little bit away from what amateurs can do here. So I think I'd better say that we're getting into the realms of professional astronomy. So let's call it a day, and let me acknowledge the fact that some of the cartoons and things that I've shown you in this short talk have been obtained from these various places, these various websites. They're in the handout if you would like to make a note of them later rather than grab them from the screen here and now. I hope you find that amusing. Thank you very much for listening.